So, welcome everyone to the third tutorial session of problem solving to programming in C. This is a SWAYAM course which has been floated by Professor Anupam Basu from Department of CSE, IIT Kharagpur, and I'm Siddhant. I'm one of the two TAs who will be helping you out with this tutorial sessions, where we will discuss questions and concepts, which will help you out with the assignments and the final exam. So this particular session is related to tutorial or assignment 3, in which we are mostly concerned with like operators and the if else statements, which are the decision making statements in C. Okay, so let's look at operators first. So there can be different kinds of operators. We have arithmetic operators, relational operators, logical, assignment, and bitwise operators. So arithmetic operators, as their name suggests, they perform arithmetic operations like addition, subtraction, multiplication, division, modulus, increment, and decrement. Okay, so can I ask all of you to kindly mute yourselves?
Yes, sir.
Right. So these are fairly straightforward operators. You just need, so all of this are, all the way till this, are binary operators. That is, they operate on two operands. So x plus y. So x and y are operands, and this is the addition operation that is happening. So uh, we say, yeah, we have some questions. Okay, but before going to the questions, I'll tell you what operator precedence is and what operator associativity is. So you have basically a table. Okay, so yeah, can you mute please? Yes, thank you. Okay, so according to operator precedence, say you have operators which are like multiplication, division, and so on. Those operators have a higher precedence than addition or subtraction operation. Okay, so I can write it like this. So division, multiplication, and modulo and modulus. These three operations have a higher precedence compared to addition and subtraction operation. Okay, so the precedence goes like this. So that means if there is a expression where there are both like operators, division, multiplication, modulo, addition, subtraction, then first we will focus on the division, multiplication, and modulo operator. And once all the operations of that has been done, we will then focus on plus and minus. Okay, that is what operator precedence means. And operator associativity. So what is operator associativity? Say you have a expression where the division, multiplication, and modulo operator occur together. Say I have a divided by b multiplied by c modulus of d. Okay, something like this. So in what way should we should we x equals this? Okay, now in what way should we evaluate this expression? So what operator associativity says is that when there are operators of similar precedence, like in this case, we have a particular associativity that is to be followed. So in both these cases we have left to right associativity. That means we will just go from left towards right, so from the left of the expression towards the right, and start evaluating. So first we will do a by b. Whatever answer we get, we'll multiply it with c, and then whatever answer we'll get, we'll do a modulo operation with d. So we'll have it has a left to right operator associativity. So I hope it's clear what operator associativity and operator precedence means, and you'll be able to,
Yes, sir.
yeah. All right, so that is for the arithmetic operators. Now we can see a few questions on that. So let's see this question. Yes.
Sir, I have a doubt.
Yeah, the one by one, please. This. Yes. Yes, we will look at that. So basically, the unary. Okay, the unary minus. Okay. You're talking about unary minus. That, yeah, yeah. This I'll tell you what that means. Um, so say you are writing x equal to minus 3 uh, multiplied by b multiplied, so minus 3 again, okay, or something like this, okay. So this is a unary operation, this first part, because it only gives a negative sign to an integer, okay. So this is a unary operations, and naturally this has to be considered, this sign has to have higher precedence than anything else here, because you need to do a minus 3 multiplied by b, right? So unary operations actually have more like higher precedence than even the multiplication division operations, because that gives you the sign of the integer, like that changes the sign of the integer. So you need to have higher precedence there. I'll give you an entire table of operator associativity and precedence at the end of this particular PDF. You can even find it on any of the websites on the internet. You can find that, but I'll just provide one just in case. You can see all the operator precedence and associativity rules there. Okay, what about the,
Sir,
yeah, sure.
sir, when will conio.h preprocessor directories to be used?
Okay, yeah, I will get back to your question. Just hold on a moment. We'll discuss at the end of the lecture. Is that fine?
Yes, sir.
Yeah.
Yes, sir. Fine.
Okay. All right. So this this is what we were discussing. So this question. So here we have taken a floating point number, which is floating point variable, which is I, and we have set the value to minus 3.0, and we are taking an integer k. We are doing I percentage 2, and we are trying to print k. So what do you think should be the output here?
Sir, is that percentage or modulus?
Yeah, percentage is the sign for the modulo operator. So as you can see, it's written here. So percentage means it's a modulo operation. Yeah.
Yes, sir. Thank you.
Okay. Okay. So the issue with this is, I'll tell you why it is a compilation error, not -1. So modulo operation does not work on floating point data. Okay. Yeah. So that is the issue with modulo operation. It can work only on integers. So this has to be like, either you define int I equals minus 3, and then you will get this k value to be -1, okay, in this case. Or you what you can do is, when you're writing int k, you have to typecast this I into integer forcibly. Then it will change minus 3.0 to minus 3, and then do a modulo 2, and this will still lead you to this. So this operation is called typecasting. Okay. So basically what you are doing is, you are converting a floating variable, which is I, to type of integer before the evaluation happens. Okay. Because you need to do a modulo evaluation here, and modulo can do evaluation only with integers. So you have to typecast the float to integer. Okay, that is one way. Or you can define the I as an integer directly instead of typecasting it. So either of the ways, you will get k equals -1 in that case. But here, if because you are trying to do a modulo operation on a floating point data, that is why you will get compilation error. Okay. So let's look at the next question. So this is a kind of question that I was just, I mean the form is pretty similar to what I was trying to explain in the earlier slide. So I hope you'll be able to solve this. So what I will do is I'll just write the values here, and I'll be expecting an answer from your side. Right. So let's see how it is getting evaluated. So first, if you remember the associativity and precedence rules, so unary plus and unary minus, then you have the multiplication, division and modulo operation, then addition and subtraction operation. So this is unary. Okay, and this is how the precedence goes, and all of this have left to right associativity. Okay, keeping that in mind, let's try to solve this. So first, this will be taken up as minus 3, the minus b part, it will be taken up as minus 3. Now after that you will have left to right, we go left to right for the multiplication, division and modulo operations. So 10 into minus 3, so that will become minus 30. So this will be plus of minus 30 divided by 2 percentage 4 plus 2 multiplied by 4. Now next the division operation will take place, so this will become minus 15 percentage 4 plus 2 multiplied by 4. Then you will have what will this be, minus 3, right? Was minus 12, then it will be minus 3 plus 2 multiplied by 4, then 10 plus minus 3 plus 8. Okay, now you have you're done with all the multiplication, division and modulo operations. So now you go into the addition operations that are left. So you will get 15 here, right? And that also will be left to right. So 10 minus 3, that will be 7. 7 plus 8, that will be 15. So here the answer you will get is 15. Is it clear?
Hello, sir.
Yes.
Sir, here minus 15 modulo 4. Can we not write it as plus 1?
So how? Okay, so you're saying that it will be minus 16, and then you'll no, that is not how it works. You can only okay, so uh, hmm like if you divide the number minus 15 by 4, okay, what do you get? So that is basically what is the meaning of the modulo operation. So when if you say if you divide minus 15 by 4, so what is your quotient? Your quotient is, I'm writing quotient. Okay, quotient is minus 3, right? And the remainder, what is the remainder? Remainder is minus 1. Sorry, minus 3 again. Yeah. So this is what you get, right? On doing the division operation.
Can we not take quotient 4
N-
and remainder
I
minus 1?
mean, no, I mean that is a division operation here that you're doing, right? Like what I want to say is minus 15.4. If you write it in the decimal, what's it going to be? Okay, I get your point, how you're trying to explain it. Like we write this as minus 4 and that as plus 1, but no, usually the operation happens in this manner. It's, I don't know why it does not happen as that, because decimal if you think in decimal terms, it will lead to the same thing. Like it will be uh, like minus 3.75, right? So you can write it as minus 4 plus 0.25, or like minus 3 minus 0.75. It's the same thing. Yes, I get that concern, but yeah, I mean it's a good question, but I'm not very sure why we can't write it as minus 4 and take a remainder of plus 1. So probably, yeah, we have to look into it a bit. But yeah, this is the way that it happens. That's all I can tell you at this point. So if it is say minus 3.75, so the remainder part will come from this part only, not like you keep the minus 3 as it is, and then like the minus 0.75. Okay, that will be the cause of the remainder. So yeah, currently that is how it works. Similarly with positive values as well. So if you have 15 by 4, so this will be 3.75. So we'll keep 3 separate. 0.75 will be our remainder, like that will be the remainder part, right? That will cause the remainder part. That will be the cause of the remainder part. Okay. Uh, all right. So okay. So next are the relational operators. So they are used to relate two different operands. So it can be just to check. So is x equal to y? So you can write it in this form. Is x not equal to y? You can write it in this form. Is x greater than y, x less than y, x greater than equal to y, and x less than equal to y. So these are all the different relational operators. This will give you expressions in terms of true and false, which is a boolean data type. Okay, so it's a boolean data type. True means yes, and false means no, right? I'm comparing it to the flowcharts that we were doing earlier. So if x is really equal to y, then you will get returned a true value, and if x is not equal to y, I mean you are writing x equals y and it actually is not equal to y, then you will get a false value. Okay, and yes.
Sir, I can't able to understand bitwise operator. So once again, please, sir. Bitwise.
I haven't even reached bitwise operators yet. Yeah, so relational, okay, so relational operators, you have true and false, and then so the integer notations of this, if you write okay, if you write a equals x equals y, okay, and x and y both are so you need an a is an integer. Okay, what happens in that case? So if this expression is true, okay, a will have a value of 1. If this expression is false, a will have a value of 0. Okay, do you understand that? And
Yes, sir.
yeah, and now I can write okay, maybe I'll discuss that after covering logical operators. So as far as this is like, if this is clear, then we'll go and look at the logical operators. So now, like if we have multiple statements like this, like we want to compare some values using relational operators, but we have multiple statements, so we use something called the logical operators, which can connect both of these conditional statements. So there is a logical AND operator, so that returns true only if both the statements are true. A logical OR operator, which returns true only if one of the statements is true. I mean, even if one of the statements is true, it still returns it true. If both are true, it will return a true. Okay, but if none are true, then it will return a false. Now a logical NOT operator, which basically just reverses whatever you get from the conditional expression, it just reverses the result. If like the true becomes false and false becomes true. Okay, now what it's negation, yes, it's negation basically. Yeah, so let me now write something which is a bit interesting to see. Okay, if I write this, like I write 4 and x equals y, and I'm saying that x is 9, y is 9. Okay, So what happens then? So this condition is true, right? Because we saw earlier with the relational operators, we are comparing the values of x and y, and it turns out that they are equal. So it's true. Now I have written 4 here. What does that mean? So 4 actually means true. So any number that is, so 0 means false. Any number other than that, okay, any other integer will be true. So if I write -4, it's still true. So unless and until it is 0,
Only integers, sir.
um,
The integers or real numbers, sir?
I think it works with real numbers as well. But the 0 false has to be exactly 0, not 0.1. Like 0.1 will be true, but 0 will be false. Okay, so I would say
Okay, decimals also, sir.
yes, like any other number would be true. Okay, now
Sir, I have a doubt regarding if and if else conditional statements.
yeah, if and if else, I'll get there. When I get there, you can ask that.
Yes, sir.
Yeah. So let us look at a few questions for that. So here we have a combination of operators. Now you have to remember that the arithmetic operators have higher precedence than the relational and the logical operators. Okay. Now I'll show you the exact table. Okay. So this is the table that you have. So you can see multiplicative, additive, then shift, then relational, right? And then like the equality or okay, the equality operators, and logical and or are much lower in the table, right? And this is how the precedence goes towards the bottom. So that basically says yeah, so that basically says that this plus, so for this particular question the plus operator has higher precedence. Then you have the less than symbol or less than operation, and then you have this and logical and operation. So this is how the precedence goes in this particular question. Okay, so let us evaluate it in that form. So first the addition operation will be evaluated. So you will have 9 less than 8.
Sir, option A, it's 0, sir, output.
Okay, let's see. It should be. You are correct. So 9 less than 8. Now 9 less than 8. Now the addition has been done, and next operation is the less than operation. So we compare it, and it turns out that it is false, right? And we do a logical and with 7. 7 is, as I said earlier, anything other than 0 is true. So false and true until both are true, and the logical and will not give it true. Okay, so because here one of them is false, this will give out false, and then we are storing the false in an integer which is x. So you'll get option A, that is 0, as the answer. So this will give a false, and now false means it's going to be 0. Okay. Okay, so let's look at the next question. So you have a couple of integers, and then you are doing a multiplication and some post increment operations here. Okay, now let us see what happens with this. So you have a equal,
Sir, I have a doubt.
yeah,
If both are false, then what will happen?
still false.
Still false?
Yes. So if both are
Yes,
false,
sir.
it will still be false. Only if both are true for logical and, if only both are true, it will give it true. In all other cases, it will give a false.
In logical operations, no, sir.
In logical and operation. So it's,
Logical and okay, sir.
yeah, yeah. So okay. So here we have two numbers, which is x equals 10 and y equals 12, and then we
Option D is the answer.
Okay, let us check that. Now we write z equals x into y plus plus. Okay, so it's a post increment operation. So what does it mean as a post increment operation? So the operation, like whatever other operation is present, that will happen first, and then the increment will happen later on. Okay, so here the other operation is the multiplication operation. So x into y will happen first, so that is 10 into 12, right? And z will become 120. After that the y value will be incremented by 1 and it will become 13. Now in the next step you have a equals x into y. Now x is still 10, but y has become 13, so this will become 130. Now we print z and a, so it will be 120 comma 130, which is option B. So that is what the post increment operation does. So whatever other operation is there, that will happen first, and then the increment operation will happen on this operand. So that is, the operand here is y, so it will increment by 1. Okay.
Sir, operator precedence is for plus plus is more than
Yes,
multiplication family.
yes, it is the highest precedence. But the post increment operation itself means that whatever other operation is there will happen first, and then the increment will happen. So like that is the meaning of that operation. If it had been, say, y multiplied by plus plus y, sorry, x multiplied by plus plus y, if it had been like this, then this was a prefix or pre-increment operation. Okay, now that pre-increment operation means first the increment will happen, and then the other operation will happen. Okay, so here
Okay, okay.
the y would become 13 first, and then z would become like 10 into 13, so this would be 130. So it's about that gets evaluated first. So here the postfix has the highest among everything, so postfix will be evaluated first. But the postfix means that first the other operation is going to happen, and then the increment or decrement, whatever we give, is going to happen. So because of the nature of the operator, that is what happens. Okay.
Okay, thank you, sir.
That means one is to be added, no sir.
Yes, one is to be added with y gets incremented by 1 because this post increment operation occurs on the variable y. So y is in.
Is there a post increment plus 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 two? You know,
Sorry.
is there any plus y plus 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 two? Like
No,
plus 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 means one, plus plus two means two.
no,
Is that
it's
available, sir?
no, it's not there. Like it has to be y plus equal to 2, which is also an assignment operation. I'll talk about it in some time. But the postfix and the prefix operation can increment or decrement the value only by 1.
Pre means subtract one.
No, no, pre means this. This is prefix and this is postfix.
In both of the cases, we will add one, sir.
Yes, in both of the cases we will add 1. Similarly, it can be minus minus y, where we'll subtract, and here it will be y minus minus. So if you want to subtract 1, but it's the order of operation that happens. So here, if it is postfix, the other operation happened first, and then the y value was incremented. If it is prefix, then first the increment happened, and then the z value was computed. Okay, so it is the order of operation that is different in the two. Okay. Okay.
Sir,
Yes.
sir, in relational expressions,
Mm-hmm.
sir, we can combine relational expressions to logical expressions, no, sir?
Yes.
Sir, means what operators through and or
And
operation we can
and or
combine.
operations. Yes.
So with not operation,
With not operation, you can only reverse the value. Say whatever you obtained from here, if I had done like this is a relational operation, which is combined with the logical operation, right? So if I put x equal to naught of this entire thing, okay, this, if I put this like the not operation, so instead of finally you got the value false, right, that will just reverse to true, and you will get x equal to 1. In that case it will become true, like this entire part inside the braces is false, so it will just like reverse whatever value you get, so it will become true, and then when you try to save it, it will get the value of 1.
So we can't combine with not operator.
Yeah, I mean, depending on what you want to check, you can combine. Okay, like it is very dependent on the case that you are trying to check. If you're trying to check that um, only in a case, so in all cases, so say I have two variables and I want to check particular values in them. Okay, so I'll check if x equals 5 and y equals 10. Okay, and I want to avoid only this case when this x value becomes 5 and y value becomes 10, so I put a not in front of it. Okay, so that will give me is when x can be anything other than x and y, the pair of variables can be anything other than 5 and 10, and then my decision making statement should work. Okay, so only in the case where x is 5 and y is 10, I want to avoid that, so I will just put a not in front of the entire expression. Do you get that? All right, so yeah, you have an example here, you can check that. So let us look at some more questions. Alright, so 10 or 0. So or, if you remember, if only if even if one of the statements, one of the relational statements is true, or gives you a true. So 10 basically means it's true, 0 means it's false, right? So this entire expression will evaluate to a true. And now I'm doing an AND operation with 10, which is again true. So this will be true and true, which will return true. So x, when you try to print x, the value will be, for true, the value will be x equals 1.
Yes, sir.
Yeah.
So true is like any integer value is
Uh,
true, no? So then
yeah.
are we considering only one? So it's
So
10, 60 or 70?
yeah, but that happens only when, okay. So when the computer has to convert a boolean value to an integer value, it will only choose 0 or 1. Okay, but when we give in a conversion of integer to boolean, so I'll just write it down. So boolean to integer, you will have either 0 or 1 depending on false or true. Okay, so boolean to integer. Now if integer I'm converting it to boolean, then 0 is still false, but anything else is true.
Okay, sir.
Yeah, so here you are printing x, in which you tried to store a boolean, so you converted a boolean to an int. That is why it is taking the value of 1, so x will be 1 here.
Hello, sir.
Yes.
Sir, same question, sir, but declares a float.
Mm-hmm.
Sir, same change.
The output should be the same even if it's a float. Yeah. Yeah. Okay, so let's look at the next question. So we have p equals 2, m equals 10, and k. Now we are combining this expression and doing a not operation here, so let's evaluate that. So what is p less than 2? No, it's not less than 2, it is actually equal to 2, so this part is false, right? Now is m greater than 2? So m is greater than 2, m is 10, so this part is true. Now we have an AND operation here, so false and true will give you what exactly? So I have false and I'm doing an AND operation with true, that will give me a false, right? Now this entire operation we are doing a not operation on this. So not of false will be true. So k will have a value of true, and k is an integer, so it will have a value of 1, right? So again here the you will have a printout of 1.
Sir,
Yes.
sir, when you will discuss assignment?
Assignment I will not discuss as such, because you are going to get the answer key for each of them. If you have any particular doubts after the assignment,
Sir, I have doubt in the expression. I am not able to understand that expression.
like which assignment?
Sir, assignment 3.
Yeah, assignment 3, it's okay. I can help you probably conceptually, but I cannot answer it directly. Okay. So, which question can you just tell me?
The third question.
Okay. Wait a moment. Third question. What is the operator that you have? Okay.
So here it
The ternary operator, the question mark and the colon.
Yes, sir. Yes, sir.
Okay. We'll look at that. We'll look at that.
Yes, sir.
Yeah. Okay. So next we go to assignment operations. So assignment operations, someone was asked. Yes.
sir, please go to the last slide.
Yeah.
Okay, here you have written printf and next line set as d.
Mm-hmm.
So is it necessary to write next line?
Yeah. The next line is not necessary here. It's like it's not required here. You could just ignore this next line. It will just whenever you print it, it will just print not in the first line, but in the second line it will print 1. Okay. So you can probably ignore that. It's not going to serve any purpose.
Okay.
Yeah. Okay. So we are looking at assignment operations now. So assignment operations basically like x equals 5. That's the most basic assignment operation. Then you have plus equal to, which we write in this form, and it means that x equal to x plus 3. Similarly with all the arithmetic operations, and then you have you can write the same with bitwise operations. I'll explain bitwise operations in a bit, but so far in the course I don't think we'll be using bitwise operations for any of the questions and so on. But in any case, I will explain it in the next slide probably. Okay. So all of these operations can be like, these are the shorthand notations. We call them the shorthand notation, because you can write both the arithmetic and the assignment operation in a single notation, right? So here we can write x plus equal to 3, and that will be treated by the compiler as x equals x plus 3. Okay. So yeah, these are the assignment operations. Then okay, do I have a slide on bitwise operations? Okay, I don't. All right. So okay, fine, let me explain it a little bit to you for those who are interested. So like I said, every integer is 32 bits, right? Like one integer, one int, say in a 64-bit computer, you have 4 bytes of memory, like for every integer, and that translates to 32 bits, right? Now I'll be talking about only 1 byte of memory here, just in just for making things simple for me. Okay. So I have 8 boxes, like every byte. So this is like 3 3 6 1 7 1 more. Yeah. So yeah, is it 8 boxes? Yeah. All right. Now similarly again we have consider another 8 boxes here. Now bitwise operation, as the name suggests, happens on the bits, that is each of these memory blocks. So each of these memory blocks has either the value of 0 or 1 stored in that. Okay. Yeah. And similarly here also you will have like 0 1 1 0 1 0 1 0. Okay. let's say something is there. Now I am doing a bitwise operation of this with this. What bitwise operation? Let's say um, let me do a bitwise AND operation. Okay, bitwise AND. So what will be the answer? So let me draw again another box with 8 parts. Yeah. Now I'll do the bitwise operation of each of these bits. So 1 and 0 will give you 0. 1 and 1 will give you 1. 0 and 0 will give you 0. 0 and 1 will give you 0. 1 and 0 will give you 0. 1 and 1 will give you 1. 0 and 1 will give you 0. 1 and 0 will give you 0. So this is the bitwise AND. Okay, basically you are doing AND operation on each of this corresponding bits. Similarly, bitwise OR, you can write it by yourself what it will be, right? So 1 and 1 or 0 will become 1. This will be 1. This will be 0. This will be 1, 1, 1, 1, 1. Okay, so this will be bitwise OR. Now then you have the the right shift and the left shift operators. Okay, yeah. So the left shift and the right shift, which basically does. Alright, so okay, so what we want, say like I said, the integer is 32 bits, right? So you have 4 boxes like this. Like you will have one more box and then one more box here and one more box here. So 4 bytes of space. Now say there are a lot of numbers stored here, right? Like all of these boxes are full. It has memory in it. It has some values 0 or 1. And what happens if I try to shift this to the left by 2? Like I write this. So let's say this is x, huh? Now x left shift by 2. That means everything here will be shifted by 2 units. So this one will go here. So I'll rewrite this somewhere. Yeah, I have to rewrite this somewhere. So it will happen something like this. The last 2 places will become 0, and this one will be left shifted by 2, so it will come here. Then you will have all the same. So everything will be shifted by 2 units to the left. Do you get what it does? So it will spill over to the next bit. So this will come here. So 3 4 5 6 7 8. Okay, now you go to this. The 0 will come here, the 1 will come here. Okay, so it will basically left shift everything by 2 units. Similarly, you can also right shift it by 2 units, which means this last 2 numbers will be just, it will vanish, and the 0 will come to the end, this and the 0, this one 0 to the second last, and then 1 1 0 1, and the digits will move from this to this box. So the right shift operator. So in the left shift operator, the last 2 bits will be lost, the leftmost 2 bits will be lost, and in the right shift operators you will have the rightmost 2 bit locations will be lost. Okay, if you are shifting by 2 units. All right, so I hope like that gives you a little bit of idea on bitwise operations, but I'll not be going into details for this because this is not part of the course as such, but you can feel free to look it up on your own.
Sir, how does bitwise AND operator denotes?
You write A and B, single ampersand. So if it is double, then double ampersand, then it is a logical AND. If it is single ampersand, then it's a bitwise AND. Similarly, a single bar would give you like bitwise OR. Okay,
Okay, sir. Okay.
yeah.
Sir, what is bitwise or?
XOR operation. Okay, So XOR operation, do you know what is the XOR operation generally, like generally speaking? So this is the bitwise XOR, this cap symbol. So the if you draw the logic gates for that, okay, 1 0 0 1 and 0 0. So the output usually for this is 0 0 1 and 1. Okay, so this is the XOR, like the um, the logic gate table for XOR operation. Okay, so if both are ones or both are zeros, it will give you 0. If either is 1, only one of them is 1, then it will give you a 1. So just do the same thing with each corresponding bits here, and that will give you the bitwise XOR operation. Is it clear?
Yes.
Yeah. Okay. Uh,
Sir, what is the use of this
Sorry.
bitwise? What is the use of this bitwise operator?
Yes, sometimes you do need to work on like on the bits directly. For example, I would ask you that you can go to the question of converting, like first of all, binary operations. If you want binary operations to be done, then you can use bitwise operators, and yeah, also you can, like swapping. You can check one of the programs would be, let's say, to swap two numbers without using a third variable. You can use a bitwise operation to do that. Yeah, and there are, like, whenever you need a bit, a level of manipulation at the bits, only then basically you use bitwise operations. That is why we are not covering here in the course, because it's not that like for beginners it is not that important to really go into this. We are not really working with the bits there. Okay, so yeah.
Thank you, sir.
Alright, now there is a different kind of classification of operators, so called unary operator, binary operators, and ternary operators, right? So basically means depends on number of operands. So number of operands in unary operator is 1, in binary is 2, and ternary is 3. Now unary operations you already know, minus a plus b. No, you don't need to really write the plus in the b part. Okay, so minus a, it's a unary operation. And like binary operation would be a plus b. Now ternary operation, let's see this ternary operator, so which is a, this is a conditional operator, this particular operator, ternary operator. So how does it work? Do I have any questions on that? Yes, I do have an example. Okay, now before that we will see a few questions again. um, so here we have x equals 7, y equals 3, z equals 5, and we are evaluating this expression. So I'll just by this point you should be able to solve this. So y is 3 multiplied by 3 percentage 5, right? Okay. Okay, now first, as you might remember, we have division, multiplication, and modulo operations with and then you have the minus, that is the subtraction operation. This is the precedence, and left to right associativity. Okay, I have to evaluate and check myself as well. So first, when you go left to right, first this operation will take place, right? So 7 minus 7 by 3. So if you go to my previous session, you will see that when I am trying to divide integers, the answer will be in integer. So this will give me 2 multiplied by 3 percentage 5. Now the next operation will be 2 into 3, which will be 6. Now the next operation will be 6 percentage 6 modulo 5, which will be 1. So then all of those operations are done, only the subtraction remains. So you do that, and that is what will be our output here, that is 6. Yeah, 6 is the answer, which is option B, like someone said that earlier. Alright, now let's look at the next question. This is a if else if. Okay, so let me go to the if else if and then come back for this question, or I'll leave it up to you as a to solve on your own. Okay, so let's look at conditional statements now. A very brief example would be like you have a few conditions which is written in form of relational operators and conditional and logical operators. Okay, so you can write a condition statement. Now the first if the condition 1 is true, then this particular block of code will be executed. Now then we go back, we close the braces, then after that else if condition 2 is true, and then this block of code is executed. So this block of code is executed if condition 1 is false and condition 2 is true. Okay, so for this block to be executed, condition 1 needs to be false, only then it will come to the else block, otherwise it will not come to the else if block. Okay, if both of these conditions are false, like condition 1 is false and condition 2 is false, then it will go to the else block. Okay, so that is basically the syntax for the if else if else statement. Now here is an example where I am using the ternary operations, the ternary operator. So yeah, so here I have a variable k, which is an integer variable and I have initialized it to 15, and I have a character c which I am trying to store based on the value of k. Now k, so this I can write it something like this, because I define a character c. Okay, then I write if k is greater than 5, then I open the braces, c equals this character, close braces, else open braces, c equals character, this character, then close braces. Okay, so this is like what this particular statement represents. So this is a ternary operation. So this is the conditional expression.
Sir, I think sir C is equal to 15.
Sorry, c equals 15. Why?
This time position in mention expression with
Yeah, yeah, so I mean, doesn't matter, I'm just giving you an example of how this ternary operations happen. So the conditional, this is the conditional expression part, and this is the if part, and this is the else part. Okay, so these are the three parts of this expression. That is why like it works on three operands, that is why it's called a ternary operator. Okay, so the three parts, the first part, yeah,
Excuse me, sir.
yes,
Sir, please explain 1 second about ternary operator. I didn't understand how it works.
okay, so let me say int, say you have k, int k is 10. Okay, and I'm defining another int x equals k percentage 2 equals 0. If that is true, then I have the value of x to be, say, something like I could write 40. If it is not, then it will be 50. Okay, now what will happen here? So this is the ternary operation. Okay, first it will evaluate this condition. Now this if they evaluate this condition 10 percentage 2, that is 10 modulo 2, 10 modulo 2, there is no remainder, so it is equal to 0. The condition is true. So if it is true, it will go and do this operation. So what is this operation? This is the assignment operation of x equals 40. If this came out to be false, it would have saved the value of 50 in x. So in this case, x will have the value of 40.
Okay, okay,
Okay.
okay.
Yeah. So that is what um, is done here.
Sir,
Yes.
I have a doubt regarding if and if else.
Uh-huh.
Regarding if and if else statements.
Yes, yes. Ask the doubt.
Uh, if else what happens when if statement is used in the place of if else?
So what happens if statement is used in place of if else if? Or sorry, I didn't get you. So this is something what will answer your question. So like multiple if else statement inside each other. Sorry, I didn't get your question. Can you write the question in the chat? Just just write it in the chat, please. Look at the output for this. So this, as you can see, is a nested if statement. So there are if statements inside the if statement itself, and you have to answer this question and tell me like what exactly it does. I think there is yeah, okay, let's see. So the first condition to evaluate is p less than p greater than q. So we'll first see, is p greater than q? Yes, that is true. So 6 is greater than 4, so this condition is true. So because if it's true, this is the block that will get executed. Now it is going to check if p is greater than r. Now I'm checking 6 against 10. Okay, so this becomes false. So that means so it will it will ignore this part. This will not be executed, rather it will go to the else part, because this condition became false. It will go and execute the else part. Now what is the else part? Printf r, which is 10, right? Oh, okay, it's not among the options. Great. So probably, yeah, I have to change the options here. So anyway, the 10 is the answer here. Okay. uh, yeah, 6 greater than 4, 6 greater than 4, true. So the true part will be executed. P greater than r, so 6 greater than 10, it's false. The else part will be executed, so percentage r. Yeah, so r is going to be printed. Okay, now right. Okay, so this is what the output will be, 10. Now what if p was, let's try some different values. Let's say p was 4, q was 6, and r is 10. So in that case, what would have happened? So p is less than q. That means you would be checking 4 less than 4 greater than 6, which is false. So in that case, this entire first block will not be executed. It will come to the else part. So now in the else part, it will check if r is greater than q. So r is 10 is greater than q, which is true. So it would print this first statement. It will not even go to the else part. It will just print this statement. So percentage r plus q. So that would be 16. Okay, in this case. So this is what will be the output for this. Just ignore the options here. And for the actual answer is 10. And if you tweak the values of p, q, and r to be like this, the answer will be 16. Okay, is that clear?
Sir, these statements are called nested statements, right?
Yes. So this is called a nested if statement. Nested if else statement, you can say. Yeah, why? Because there are one in between like there is a if, then inside that there is further if else, then there is a else, in that again if else. So nested. Yeah.
Yes, sir, yes.
Okay. So let me see if there are any questions in the chat. Yeah.
Can you explain the previous question once again, sir? I had a network issue.
Yeah, so basically this is called a nested if else statement. So here you have, let's say for this example, you have p equals 6, q equals 4, and r equals 10. So first you evaluate the outer loop or the outer if. You see 6 is greater than 4. Yes, that is true. So if that is true, then we will execute this block only. We will forget about the else block. We'll just ignore that. Then inside this block, again you have the inner if statement, which is checking if p is greater than r. That means you're checking 6 to be greater than 10, which is false. That means the part associated with the true will not be executed. So this first printf is gone. We'll go to the else part and we'll print this r value, like the value of r. Okay, and the value of r is 10. So here the answer will be 10. But what if you change the values such that p is now 4, q is 6, and r is 10? So what happens in that case? So you check here, p is greater than 4 is greater than 6, which is false. So you ignore this first entire block and you come to the else block. Now in the else block, the first thing that you have to check is if r is greater than q, and r is 10, q is 6. Okay, so that is true. So if it is true, then the first printf statement here inside the if, inside the inner if block will be executed, which prints a value of r plus q, and r plus q is 16. So that will be the answer, and the else part will just be ignored. Okay, so this is what overall I was just saying.
Okay, sir. Thanks for your discussion.
Yeah. Okay, so now a few more questions on um, the if else statements. Okay, so here you have, yeah, this is pretty straightforward because I have already told you what 0 and 0.5 and minus zero point 0.5, how will they be treated. So I have already told you that, so you should be able to answer this right away. um, okay, and this as well is quite easy. So here you have not of x. So x was 17. So okay, let me write it. So I'm expecting to hear the answer for the left question from you. So not of 17, not again, and y is 1. Yeah. Okay. So now what I have to see is the relational operators. Logical and, logical or. Okay, cool. Cool. Yeah. Alright, so what happens here? You have not of 17. 17 means it's true. Not of 17 means it's false. Then you do another not of it. Okay. And then you do a and with 1. So not of false is true. And 1 is also true. So this is true. Now if it is true, then this part will be executed, right? Not the if part will be executed. So you're printing 17. What is up with what is up with the options today? Yeah, so here the value will be 17. Okay. Yeah, right, so the value will be 17 here, like the answer will be 17. Alright, and here what happened? So if of 0, 0 means it's false, right? So false, then this part is not going to be executed because it's in a if. And then you write another if statement, if of 0.5. 0.5 means it's true. So if it is true, then it prints this. So Java will be printed. Okay. Then again minus of 0.5 means it's true. So if it's true, again Python will be printed. So answer is Java and followed by Python on the next line. Okay, so this is going to be the output for this one.
Sir, those statements are called simple if statements, right?
Yes, you could call it a simple if statement. Yeah.
Okay, sir. Sir, in right question, if we have the last answer
yeah, it will print y. If this entire expression, say you put x equals 0, okay, in that case not of x will be like true, and not of true will be false. So false and y, which will be true, that means overall it will become false. If that becomes false, then the else part is going to be executed. So else part means it is going to print y, it will print 1.
Okay, sir. Thank you.
Yeah.
Sir, in the
Yes.
left value, where is the value?
Sorry, in the left one.
Where there is no value is mentioned, sir. How we define?
Sorry, what value are you talking about? Okay, so there is no variable has been defined. Yes. So basically this question is just trying to check whether, like, this is a sample question. Don't when you write any code, you will definitely be using variables. So this code just wants to check the concept of, like, this true and false. If you put like any number other than 0 and 0 in the relational expression. So in the conditional expression I have put here only 0, that means it's a false expression. So if it is false, then the part under if is not going to be executed. So if there was a else statement, that would have been executed, but there is no else statement here, so nothing happens. So next, you put zero point 0.5 in the conditional expression, and that is evaluated as true. So anything other than 0 is true, so zero point 0.5 is also true, and that being true, the if part is going to be executed, which prints Java. Now again we come to another if statement. So in this if statement you will have minus of 0 0.5, which is also true. Now if it is true, then the if statement will be like the block of statements under if will be executed, and that will be just printing Python. So that is why we have Java and Python being printed here. So this question is only to check like what happens. It's a sample question. When you will be writing your programs, you will definitely be using variables to do that.
Okay, sir.
Yeah. Okay. Right. So what I'll do is I will discuss the okay, wait a minute. Yeah.
Sir,
So yes.
can you go to the back slide?
Mm-hmm.
So back slide.
Yeah.
So this, how to solve this second question?
Okay. So here not of 17. So this was what we had written, right? This is like I've just put the values here. So not of 17. Not of 17. What is 17? 17. So anything other than 0. 0 is false. Anything else is going to be true, right? I told you that before.
Yes,
Now,
sir.
so 17 means it's true. Now not of true means it's false. Okay. Now again, not of false means it's true, because what not does is it reverses the value. So earlier it was 17, which was true. Now it became false. Now again there is another not, so it will become again true, and then you will have the AND operation. The AND operation with 1. 1 means it's true again. So true and true will give you true. So if it is true, then it will, because this conditional expression was evaluated to be true, the if part will be executed. So the if part contains the printing of the value of x, and that will be 17.
Okay, sir. Sir, how do we represent factorial of any number?
Represent, like, what do you mean, like the code?
Yes, sir.
So I mean I can just say that the factorial of a number is basically 1 multiplied up till that number. Like, the rest you have to figure out. I think it's a question in the assignment, right? So you have to multiply all the numbers till the number x. So this is the factorial of x.
Okay, sir.
Yeah.
Sir, then how we can get to know about this is not or this factorial?
No, I mean that is this symbol is used in C. It is used as a not, logical not. this symbol is invalid in C. It is invalid in C. Okay, you might know this as a factorial symbol, but in C it is not recognized as a factorial symbol. It is only recognized as the exclamation mark is recognized only as logical not.
Okay, sir.
Yeah. Okay, so
So,
yes,
sir, anything other than 0 will be true, sir.
anything other than 0 will be true. Yes,
Even though it is if the number contains minus symbol.
yes, even if it contains minus symbol.
Okay, sir. Thank you.
Yeah,
Even it contains like root 3, root 3.2,
you
like
cannot,
that.
but root 3 you cannot write, right? I mean, is there a way to write root 3 in C? Like if you put minus of square root function of 3.0, it will still be like anything other than 0 will be false. So you can write, like there is a math function, I don't want to go into that, but if you write say if of minus sqrt of 3, okay, it will still be like true. Okay, so sqrt is a function for the square root. Yeah, so this will still be true. Yeah. Okay, so now, okay, for this question, this expression, you need to know how it is evaluated. So here basically it's like 29 greater than 15 greater than 4. Okay, so relational operators, so both of these are greater than operations and relational operations, so we need to check. So relational operations have a left to right associativity, so that is what we will follow. So we'll just go from left to right. Okay, so left to right, 29 greater than 15, what is that? It is true, right? So now it becomes true greater than 14. True means it's 1 greater than 14. Okay, and 1 greater than 4, 1 greater than 4 will be false. So this entire expression turned out to be false, so here you will get false being printed. Is it clear?
Yes, sir.
Okay, then let's see kind of another question. So x has the value of 10, and our if statement we are writing x is greater than 0, and which is true, right? X is greater than 0 because it has a value of 10, so this is true. So true means you will have to print this, which is inside if, right? Inside if is getting printed. Then after that, what happens? You have a else if statement writing x is greater than 0 again. Okay, so but you need to remember that once this condition, this if condition has been evaluated to be true, it won't even check the other conditions anymore, like the else if and the else part, it won't check. So only this one will be printed, that is the inside if. So the answer here will be option A. So it won't even go to check the else if and the else part. If this condition is true, this one, it is true, then so in that case it won't evaluate the else if and the else conditions, and in that because of that your answer will be only like inside if here.
Sir,
Yes.
sir, can you please explain the first question again?
Yeah, sure. So here in the first question we have three like two relational operators close by. So 29 greater than 15 greater than 4, that's how it is. And for relational operators, that is this greater than symbol, uh, as you can see both are the same symbol, so they have the same precedence. Now the associativity says that we should evaluate it from left to right. So we start evaluating it from left to right. So 29 greater than 15, which is true, and true means it's 1, right? And 1 greater than 4 is false. So overall this expression turned out to be false, and because it was false, this became false, so it will go and print the else part, like it will go and execute the else part of the statement, and here else contains only this printf, which prints the false, like in capital. Okay, so that is why the answer will be option B. Yeah. Alright, now I can go back to this question, but it is quite similar to the one that we saw earlier. So x equals 0. Now inside this if statement I am doing a x plus plus, that is a postfix increment. So if you remember what postfix increment is, the other operation will happen, then the increment will happen. Okay, now that means I am evaluating here if of 0. And what is if of 0? This is false, right? So if it is false, it will go to the else if part. But before going to the else if part, the x value will be incremented by 1. That means it will become 1. X will go from 0 to be 1. And here it will evaluate else if x equals 1, which now is true, right? X is now 1, so it will print false. So false will be the answer here.
Sir,
Yes.
sir, in the given if x plus plus, then print f as given as true, sir.
Mm-hmm.
But if x plus plus means then it will be 1 only, no, sir. So if of 1 only will be coming, no, sir.
No, but x plus plus means it's a post increment operation. In post increment operation, always first the other operations take place, then the post increment takes place. So the evaluation here will happen as if of 0 without the, that is, no increment has taken place so far. After this evaluation is done, only then the x value will be incremented by 1. So this operation occurs first. The if of 0 occurs first. After the evaluation of this is done, only then the x value will increase by 1. So this part, as you can see, if of 0 means it will be false, and false means it will go to the if else part. Okay, now before the if else part is executed, the increment operation will take place. So x will become 1, and then it will then it will check if else if x equals 1, which is now true because x has been incremented by now. So it becomes this condition becomes true, and it prints whatever is in the if else else if block, that is this option B.
Excuse me, sir.
Yes.
So if we have the their prefix implementation, then what will be the output is?
Yeah, if it is plus plus x here, then you will have if of 1, right? Because the increment occurs first and then you are evaluating, so x will become 1 first and then you will evaluate this. So this is true. If this is true, then you will have true being printed, that is option A. Okay.
Okay, sir.
Yeah.
Sir,
Yes.
if part is satisfied, then it will not go to else if part, no, sir.
Yes, if it is satisfied, then it will not go to else if part. Yeah. Okay, so these are all the questions I had for you. This is the table for the operator associativity and precedence. So this is the precedence part. Okay, the precedence goes down like this, and the operator associativity is um, like you can see from right to left or left to right, and yeah, so that is basically what it is for today's class. So if there are any questions, you can ask them now. Okay, let me go back to the assignment operators. Yeah.
Sir, could you please explain last four assignment operators? Last four.
This.
Yes, sir. Yes.
Yeah, this is like these are the bitwise operations. So bitwise and assignment both. So if you have understood this, what I was explaining with the bitwise operations here, so basically that will,
Bitwise or operator, sir?
yes, bitwise OR. This is basically bitwise OR. So you're doing a bitwise OR between x and 3 and saving the value in x. Okay, here you are doing a bitwise XOR between x and 3 and you are saving the value in x. Here you are doing a left shift, a right shift by 3 units and then saving the value in x. And here you are doing a right shift. This is a left shift by 3 and you are saving the value in x. So these are all bitwise and assignment together. Okay, yeah.
Sir, how we call last to third one?
Last two, sorry.
Last to third one.
The third one, this one. Okay, this is like,
Yes, sir.
okay, this is the bitwise XOR operation. So I can write it here. This is bitwise XOR, XOR.
Okay, sir.
Yeah.
Sir, if x equal to 0,
Yeah. Because x equals x plus plus. Okay, yeah, that is a whole other ball game. Yeah, no. X equals x plus plus. That is a special condition. Okay, probably I'll have a question regarding that in the next tutorial. So it is a very special condition that happens. So x equals x plus plus and x equals plus plus x. So you are permitted to do this. Okay, this is fine. You will get a value of 1, but this is a very special case. Okay, here there will be no no increment occurring at all, because you can think of it in this way that uh, okay, yeah, I mean I have to go a bit into detail to explain this special case, so probably I'll do it along with the question in the next session. So this is a very, but you can keep in mind that this is a very special case, and yeah, it will not increment or decrement or do anything in this case. But in the prefix one, it will simply increment it, like you will get a x equals 1. Okay, yeah, yeah, sure. Okay, so someone was asking about conio.h. So it's a console input output file, and it has like some functions which you can use to enter characters and so on. So a few of the functions are defined under that, and a few of the functions are defined under like stdio.h. So if you use the functions that are defined under conio.h, you have to put conio.h. For example, you have this character entry functions get ch and get line and so on. Those are defined under conio.h. So if you want to use them, you have to include conio.h. Why you will use them, we'll see when we discuss strings. Why this get line or get s or put s, these all are like important. These functions are important to use. When we learn strings, we will probably look into that. But for now, you can just know that stdio.h and conio.h both are input-output header files. Some of the input-output functions are defined in stdio.h, some others in conio.h. That's all. All right. Right. So that is the data type of the int function. The why we declare int before the main function. So that is the data type of the int function. Why every function needs a data type, we'll see it when we discuss functions itself. Okay, so for now just write the int main and return 0. So that will be clear once we go to the functions part of things. Okay, so this is where I'll end the session. Thank you all for joining. So we'll meet next Tuesday around at 6 p.m. For discussing week 4 lectures and a few tutorial questions for that. All right, thank you.